All right, welcome back. So I'm gonna move in a bit of a different direction. I still will be reading this book, but I'm right now I'm watching the Welcome to the Agents course. If you haven't heard of Hugging Face, and apparently I haven't because I'm not subscribed. It's like it's social media for people who want to learn AI, which is like such a cool concept. It's like Twitter or Blue Sky or LinkedIn or Facebook, but for people who want to learn AI. So here's my account on it. Username is gposh, um, and you can actually like follow people. So there's like yeah, so here's posts. So these are like hosts posts like as if it were a social media account. So really cool concept, social media designed around open source learning of a new and novel technology. I love it. So um okay, so somebody gave me I see. So so what we got here is in one of my prior videos, I pointed out that they actually do have courses on Hugging Face. Now they have a brand new course released very soon, very recently. It's called the Agents course. So back to this video here. This video is live right here, right
Okay.
now. Um, so right now they're just answering questions, and they just finished giving a presentation for about a half an hour on what you need to do to complete the
I think
course.
I
So
think
let's go and look at some of the timelines. We should be able to find the schedule pretty easy. Yeah, so it should be after this slide. Here we go. So if you finish the course by May 1st, 2025, you get a special certification that no that they won't be offering. So you get a rare limited time certification. You get a course completion certification. Now it doesn't have to be, I guess that timeline is not going to be set in stone, but basically, you get this whole community of people, coming together to learn a new and novel technology. They have near 80,000 subscribers, and there are 8,000 people watching this right now. So, what more could you possibly ask for, right? So, like, I'm going to be shifting into this and trying to focus on this. So this video is to show that, and in fact let's go and actually work on the course. So all you got to do is go to huggingface.com, create an account, and then I'm not sure exactly how to, you could search for agents course. And yeah, under organizations, uh it'll say agents course students. um and Yeah, so I'll follow this. There's only 16 other students there, but if we go to the agents course, we can see there are um, 11,000 people enrolled in this course. So this is how you can find it. Make sure to follow them, and then you can start the course by registering for it here, which is something I already did, um, I think. Yeah, I already registered it, and now you can look at the syllabus and everything by going to this link. Uh, yep, so check out the course material here, and there we go. So now you can start working on the course. So that's what I'm gonna do is uh, spend this video getting through. If we click on the last one, we can see that. Uh, this course is going to be published in an ongoing manner, so not even everything is published yet. So I won't be able to work on the bonus unit until next week. But now I can work my way through Unit 1. So let's do that. All right, so here's Unit 0. Welcome to the AI Agents course. Welcome to the most exciting topic in AI today, agents. This free course will take you on a journey from beginner to expert in understanding, using, and building AI agents. The first unit will help you on board. So it'll help you to discover the this first unit. So Unit 0, the first unit, Unit 1, will go into more depth, but here we're going to focus on discovering the course's syllabus, choose the right path you're going to take, either self-audit or certification process, and I'll be taking certification process for sure. Get more information about the certification process and deadlines, unless they're charging an arm and a leg for it. Get to know the team behind the course, create your Hugging Face account, check out our Discord server, and meet your classmates and us. Let's get started. We organize a live QA this Wednesday, February the 12th, 5 p.m. CET. So I think a lot of this is out of Europe. The people who were running this live stream that I was just showed, and that is actually still going on right now, were from France and Belgium, where we explain how the course will work, scope, units, challenges, and more, and answer your questions. So here's the link, and it's still live, but if you're watching this later, it might not be live for you, but if you're watching this before the 18th, you can still get on board and finishing up that unit 1 and 2 before unit 3 is released could probably be something possible. If you're watching this past March 3rd, then uh, I think you can definitely still do the course. It's going to be up now pretty much per perpetuity, and then you can still get you can still get the certification and you can get the certificate as well. All right, so don't forget to click notify me to not miss the live. So there we go, already got that. So what to expect from this course? In this course, you will study AI agents in theory, design, and practice. Learn to use established agent libraries such as Small Agents, LangChain, and Llama Index. Share your agents on Hugging Face Hub and explore agents created by the community. Participate in challenges where you will evaluate your agents against other students. Earn a certificate of completion by completing assignments, and more. At the end of this course, you'll understand how agents work and how to build your own agents using the latest libraries and tools. Don't forget to sign up to the course, which I think I did. Um, uh, so, uh, yeah, so I did this already. We are respectful of your privacy. We collect your email address to be able to send you links when each unit is published and give you information about the challenges and updates. Yep, so I received a link. What does this course look like? The course is composed of foundational units where you learn agents concepts in theory, hands-on, where you'll learn to use established AI agent libraries to train your agents in unique environments. These hands-on sections will be Hugging Face spaces with a pre-configured environment, and use case assignments where you'll apply the concepts you've learned to solve a real-world problem that you'll choose. The challenge, you'll get to put your agent to compete against other agents in a challenge. There will also be a leaderboard, not available yet, for you to compare the agent's performance. This course is a living project, evolving with your feedback and contributions. Feel free to open issues and PRs in GitHub and engage in discussions in our Discord server. After you have gone through the course, you can also send your feedback using this form. What's the syllabus? Here is a general syllabus for the course. For more detailed List of topics, oh, a more detailed list of topics will be released with each unit, but broadly, there are going to be four chapters. The first chapter is the zeroth chapter, which is just kind of before you get started. So it's the onboarding. It it's to set you up with the tools and platforms that you will use. Then we've got agent fundamentals. Explain tools, thoughts, actions, observations, and their formats. Explain LLMs, messages, special tokens, and chat templates. Show a simple use case using Python functions as tools. Then we've got frameworks. Understand how the fundamentals are implemented in popular libraries, which are Small Agents, LangGraph, and Llama Index. Yeah, I feel like there's a typo. There's a typo because I noticed that they said laying chain. And I didn't think Lane Chain was a agent's. Yeah, I didn't think this was a was a I didn't think this was a something for agents. So let's see what the difference is between LangGraph and LangChain. Yeah, they meant that, oh, okay. So LangGraph comes from LangChain though. Okay, so they're kind of interchangeable in a way. All right, so use cases. Let's build some real life use cases open to PRs from experienced agent builders. And then the final assignment would be build an agent for a selected benchmark and prove your understanding of agents on the student leaderboard. We are also planning to release some bonus units. Stay tuned. What are the prerequisites? To be able to follow this course, you should have a basic knowledge of Python. I do. Basic knowledge of LLMs. I certainly do from reading this book and reading various other things. We have a section in Unit 1 to recap what they are. Yeah, I've done all kinds of things in the past to have a basic knowledge of LLMs. I've done the Fast API course. I've read Machine Learning for Network and Cloud Engineers. I've been reading this book here, so certainly have that as well. What tools do I need? You only need two things, a computer with an internet connection, a Hugging Face account to push and load models, agents, and create spaces. If you don't have an account yet, you can create one here. It's free, and I do have an account, and I'm logged in. So here you go. You need a computer. Got that. Hugging Face account. If you don't have one yet, you'll need one. It's free. And this was a really good question that I saw that come up in the live screen. Do you truly just need this, a computer, or do you need a AI home lab sort of rig thing? Well, they say to complete these courses, you truly just need a computer. If you're going to go off on your own and build some product or tool, yeah, you'll probably need a an in-home or a which is what I'm reading about in this book right now. You'll need to buy or build some real juice, some real horsepower. But to just complete these courses, all you need is the computer you already have. The certification process, three paths, choose your own adventure. So you can participate as an auditor. You can participate in all challenges and do assignments if you want, but you have no deadlines. That's not the path I'll be choosing. The next one is earn a certificate of fundamentals by completing the first unit and not completing the rest of them. That's not what I'll be doing. And that one is a good option for managers, for product managers, for like directors, for like people who need to make big decisions about like the AI, but their job isn't to put their ass in the seat and actually type out the code. You can stop there. But if you're like me, you're going to go for both a fundamentals and completion certificate. By completing Unit 1, a use case assignment, and the final challenge. You can choose to follow this course in auto audit mode or do the activities and get one of the two certificates we'll issue. If you audit the course, you can participate in all the challenges and do assignments if you want. You don't need to notify us. The certification process is completely free. To get a certification for fundamentals, you need to complete Unit 1 of the course. This is intended for students that want to get up to date with the latest trends in agents. To get a certificate of completion, you need to complete Unit 1, one of the use case assignments, and will propose during the course. Well, one of the use case assignments will propose during the course, and the final challenge. There's a deadline for the certification process. All assignments must be finished before May 1st, 2025. So lots of time to work with. Should be pretty easy. So the course deadline, there's a deadline for the certification process. All the assignments must be finished before May 1st, 2025. Should be able to hit that target pretty easily. What is the recommended pace? Each chapter in this course is designed to be completed in 1 week with approximately 3 to 4 hours of work per week. Easy. Since there's a deadline, we'll provide you a recommended pace. It'd be great if I could go over this pace, but we saw that they're not published yet. So this is just a recommendation. You can follow the course at your own pace, but you do need to hit this final deadline. There's about 3 to 4 hours of work per week. So there's about 16 hours per month. So the earliest you could probably finish this is by the end of this first week in April. All right, so the recommended pace will be, yep, so this should be done already, but you have until the 17th when the next one's released, and so on. So the good news is there's no individual unit deadlines. So if you're behind the curve like I am, um, uh, that's okay. There's no deadline to go forward with the next one. How to get the most out of the course? To get the most out of the course, we have some advice. Join study groups on Discord. Studying in groups is always easier. To do that, you need to join our Discord server and verify your Hugging Face account. Do the quizzes and assignments. The best way to learn is through hands-on practice and self-assessment. Define a schedule to stay in sync. You can use our recommended pace schedule below or create yours. Okay, so who we are, Jeffrey Thomas, or Joffrey Thomas. Um, so Joffrey is a machine learning engineer at Hugging Face who has built and deployed AI agents in production. Joffrey will be your main instructor for the course. So you can follow, remember, social Hugging Face is meant to be another kind of social media as well. It's an alternative to X or LinkedIn. So you follow these people on Hugging Face and use it as a social media. So I'm following all three of the instructors already. The next instructor is Ben Burtonshaw. Ben is a machine learning engineer at Hugging Face and has delivered multiple courses across various platforms. Ben's goal is to make the course accessible to everyone. Then Thomas Simonini. Oops, and yeah. So Thomas is a machine learning engineer at Hugging Face and delivered the successful Deep RL and ML for Games courses. Yeah, so those should be here. So ML for Games. Yeah, so we got this one here, ML for Games. That might be a good one to do next. And then Deep RL is another one. Yeah, so kind of order those up like that. All right. Acknowledgements. We would like to extend our gratitude to the following individuals for their individual contributions. Let's see if we can follow these people as well. So, guidance and expertise in reviewing, amazing demo spaces, decoding and final agent, amazing demo space on tokenization. Follow each of them. All right, so there we go. So I found a bug, or I want to improve the course. People know me; I can be a pest. So I'm looking at this. So if you found a bug in a notebook, please open an issue and describe the problem. If you want to improve the course, you can open a pull request. If you want to add a full section or new unit, the best is to open an issue and describe what content you want to add before starting to write it so we can guide you. I still have questions. Ask your question in our Discord server. Now that you have all the information, let's get on board. So we can click here to the onboarding. But let's go back to the to just the welcome to the course, and I'm gonna create a new bookmark under career. It's gonna be we'll just call it Hugging Face. All right, and drag that to the top, and then we'll do courses inside of that. Okay, and now bookmark this to the Hugging Face courses. Oops, and I misspelled courses. That's okay. Let's go back and try to spell it correct. Okay. Um, and let's add each of these to that folder. All right. Perfect. Okay, so now we're on onboarding, your first steps. Now you'll have all the details. Let's get started. We're going to do four things. Number one, create your Hugging Face account if you have not already. I have. Sign up to Discord and introduce yourself. Don't be shy. I did that. Follow the Hugging Face Agents course on the hub. I think that's GitHub. I don't know what they mean by the hub. I wish they were more clear about that. I don't know if I don't know if Hugging Face itself has a hub or if they're talking about GitHub. I think they're talking about GitHub, so I'll just star that. Um, Spread the word about the course. So that's what I'm doing, making this video here. So step one, create your Hugging Face account. Did that already, can skip that. Join the community on Discord. Did that already, can skip that. Follow Hugging Face organization, clients course organization. So we can click here and on the social media component of Hugging Face. We have the option to follow, and I already did that. Spread the word. So doing that by making this video. Oh, and they're right. Yeah. So the repository would be on GitHub. Uh, yeah, I mean, I already started. Perfect. Okay, and here's what you can use to share. So there we go. All right, so on to the next one. Now this is optional. This is Discord 101. Um, I've already used Discord pretty extensively. Um, so here's one. So you can format text using a markdown style, which is especially useful for writing code. Um, Note that Markdown doesn't work as well for links. Consider opening threads for long conversations to keep discussions organized, and that's all there is to that. All right, so Unit 0 is knocked off. I'm gonna try to knock off Unit 1. So this is Introduction to Agents. Welcome to this first unit where you'll build a solid foundation in the fundamentals of AI agents, including understanding agents. What is an agent and how does it work? How do agents make decisions using reasoning and planning? The role of LLMs, large language models, in agents. How LLMs serve as the brain behind an agent. How LLMs structure conversations via the messages system. Tools and actions. How agents use external tools to interact with the environment. How to build and integrate tools for your agent. The agent workflow. Think, act, observe. After exploring these topics, you'll build your first agent using small agents. Your agent named Alfred will have a simple task and demonstrate how to apply these concepts in practice. You'll even learn how to publish your agent on Hugging Face Spaces so you can share it with friends and colleagues. Finally, at the end of this unit, you'll take a quiz. Pass it and you'll earn your first course certification, the graduate certification, the certificate of uh, fundamentals of agents. All right, so this unit is your essential starting point, laying the groundwork for understanding agents before you move on to more advanced topics. So this is a big unit, so do take your time and don't hesitate to come back to these sections from time to time. So if you're like me and you're doing this close to the date of February 12th, the next unit hasn't even been released yet. So yeah, you can take time with this. So step one would be to understand what are agents. Step two would be learn what are LLMs and messages system. Step three, study tools and actions. Step four, learn the agent workflow. Step five, code your first agent. And then step six is take the unit quiz, and you get a certification for that. All right, so we'll have a live Q&A this Wednesday, February 12th at 5 p.m. Yep, so already looked at that. I wonder if that's still going on. If it is, it's been, yeah, it's still going on. Oh, wait, no. Okay, it ended. Yeah, it ended. Okay. All right. Well, now regarding the quizzes, I think what I might do is read everything and then pause it and take the quiz off and just show the results because I don't want to ruin it for anyone. I mean, I understand like if you just want to see uh my reasoning versus your reasoning, like that might be helpful. But you know, there are places to go for that, the Discord, everything like that. So I don't know. It's I, I I don't know. All right, so by the end of this section, you'll feel comfortable with the concept of agents and their various applications in AI. To explain what an agent is, yes, let's start with an analogy. The big picture, Alfred the agent. Meet Alfred. Alfred is an agent. Imagine Alfred receives a command such as, Alfred, I would like a coffee, please. Alfred, I would like a coffee, please. Because Alfred understands a natural language, he quickly grasps our request. Before fulfilling the order, Alfred engages in reasoning and planning, figuring out the steps and tools he needs to, number one, go to the kitchen, number two, use the coffee machine, number three, brew the coffee, number four, bring the coffee back. Reason and plan, toolbox, there we go. Once he has a plan, he must act. To execute his plan, he can use tools from the list of tools he knows about. In this case, to make a coffee, he uses a coffee machine. He activates the coffee machine to brew the coffee. All right. Finally, Alfred brings the freshly brewed coffee to us. Your coffee, sir. Thanks, Alfred. This is what an agent is, an AI model capable of reasoning, planning, and interacting with its environment. We call it agent because it has agency, aka it has the ability to interact with the environment. So, user request would be bring me a coffee. Step one, think and plan. Select the tools needed to bring a coffee. Step two, act using those tools. Let's go more formal. Now that you have the big picture, here's more precise definition. Here's a more precise definition. An agent is a system that leverages an AI model to interact with its environment in order to achieve a user-defined objective. It combines reasoning, planning, and execution of actions, often via external tools, to fulfill tasks. Think of the agent as having two main parts. Number one, the brain AI model. This is where all the thinking happens. The AI model handles reasoning and planning. It decides which actions to take based on the situation. Number two, the body, capabilities, and tools. This part represents everything the agent is equipped to do. The scope of possible actions depends on what the agent has been equipped with. For example, because humans lack wings, they can't perform the fly action, but they can execute actions like walk, run, jump, grab, and so on. What type of AI models do we use for agents? The most common AI model found in agents is an LLM, large language model, which takes text as an input and outputs text as well. Well-known examples are GPT-4 from OpenAI, Llama from Meta, Gemini from Google, etc. These models have been trained on a vast amount of text and are able to generalize well. We will learn more about LLMs in the next section. It is also possible to use models that accept other outputs as the agent's core model. For example, a vision language model, VLM, which is like an LLM, but also understands images as input. We'll focus on LLMs for now, and we'll discuss other options later. How does an AI take action on its environment? LLMs are amazing models, but they can only generate text. However, you ask a well-known chat application like Hugging Chat or ChatGPT to generate an image, they can. How is that possible? The answer is that the developers of Hugging Chat, ChatGPT, and similar apps implemented additional functionality called tools that the LLM can use to create images. Can you generate a picture of the Eiffel Tower made of broccoli? Okay, there it is. We will learn more about tools in the tools section. What type of tasks can an agent do? An agent can perform any task we implement via tools to complete actions. For example, if I write an agent to ask as my personal assistant, like Siri on my computer, and I ask it to send an email to my manager asking to delay today's meeting, I can give it some code to send emails. This will be a new tool the agent can use whenever it needs to send an email. We can write it in Python. So we can write a Python function for it to use. In this case, the name is send underscore message underscore to, and then there's two parameters, recipient and message. So useful to send an email message to a recipient. The LLM, as we'll see, will generate code to run the tool when it needs to, and thus fulfill the desired task. So send message to the manager, can we postpone today's meeting? The design of the tools is very important and has a great impact on the quality of your agent. Some tasks will require very specific tools to be crafted, while others may be solved with general purpose tools like web search. And I'll do a sound check here. It looks good. Note that the actions are not the same as tools. An action, for instance, can involve the use of multiple tools to complete. Allowing an agent to interact with its environment allows real-life usage for companies and individuals. Example 1, personal virtual assistants. Virtual assistants like Siri, Alexa, or Google Assistant work as agents when they interact on behalf of users using their digital environments. They take user queries, analyze content, retrieve information from databases, and provide responses or initiate actions like setting reminders, sending messages, or controlling smart devices. Example 2, customer service chatbots. Many companies deploy chatbots as agents that interact with customers in natural language. These agents can answer questions, guide users through troubleshooting steps, open issues in internal databases, or even complete transactions. Their, their predefined objectives might include improving user satisfaction, reducing wait times, or increasing sales conversion rates. By interacting directly with customers, learning from the dialogue, and adapting their responses over time, they demonstrate the core principles of an agent in action. Example 3, AI non-playable character in a video game. AI agents powered by LLMs can make non-playable characters, NPCs, more dynamic and unpredictable. Instead of following rigid behavior trees, they can respond contextually, adapt to player interactions, and generate more nuanced dialogue. This flexibility helps create more lifelike, engaging characters that evolve alongside the player's actions. To summarize, an agent is a system that uses an AI model, typically a LLM, as its core reasoning engine to understand natural language, interpret and respond to human instructions in a meaningful way, reason and plan, analyze information, make decisions, and devise strategies to solve problems, interact with its environment, gather information, take actions, and observe the results of those actions. Now that we have a solid grasp of what agents are, let's reinforce your understanding with a short ungraded quiz. After that, we'll dive into the agent's brain, the LLMs. All right, so here's where I'm not sure if I should just if I should. I mean, it's ungraded, but let's see here. So up to this point, you should have understood the big picture of agents, what they are and how they work. It's time to make a short quiz, since testing yourself is the best way to learn and avoid the illusion of competence, which I like this. Oh, cool! This is a whole. This is oh, I like this. Cool. That's a good one. This will help you find where you need to reinforce your knowledge. This is an optional quiz and it's not graded. So, what is an agent? Which of the following best describes an AI agent? And this is optional, ungraded. Spoiler alert, though, I am gonna do these here live on camera. So I will be giving away the answers, but, so you can pause it and do it on your own or whatever. All right, question one. What is an agent? Which of the following best describes an agent? So we have to pick one from these four answers. So, okay, so I'm going to go with B, and we'll see what I get at the end. So, what is the role of planning as an agent? Why does an agent need to plan before taking an action? Um, okay. So these are all pretty easy. How do tools enhance an agent's capabilities? Why are tools essential for an agent? Okay. All right. Yeah, pretty. Okay, so how do agents differ from tools? What is the key difference between actions and tools? All right. Um, so what role do large language models, LLMs, uh, play in agents? So how do LLMs contribute to an agent's functionality? Okay. Which of the following best demonstrates an AI agent? So which real-world example best illustrates an AI agent at work? Okay. Uh, Okay, so let's see what I got. So I click submit. Oh, I got that one correct. Submit, correct. Submit, 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 submit. Okay, and this is ungraded, so it's not going to go through larger, but for each of these, I clicked submit, and I got everyone correct. All right, so the next section, what are LLMs? In the previous section, we learned that each agent needs an AI model at its core, and that LLMs are the most common type of AI models for this purpose. Now we will learn what LLMs are and how they power agents. This section offers a concise technical explanation of the use of LLMs. If you want to dive deeper, you can check out our free natural language processing course. What is a large language model? An LLM is a type of AI model that excels at understanding and generating human language. They are trained on vast amounts of text data, allowing them to learn patterns, structure, and even nuance in language. These models typically consist of many millions of parameters. Most LLMs nowadays are built on the transformer architecture, a deep learning architecture based on the attention algorithm that has gained significant interest since the release of BERT from Google in 2018. So these are all very familiar based on what I've been reading here and other things. So the original transformer architecture looked like this with an encoder on the left and a decoder on the right. So wish I could see this a bit more clearly. Okay, there we go. Perfect. So the original one, inputs go through input embedding. Then we have this symbol. I'm not sure what this means. Then it goes to, it can either go add and norm, or it can go to multi-head attention, feed forward, add and norm, multi-head attention, add norm, feed forward, add norm, add and norm, output shifted right, output embedding, linear softmax output probabilities. So not sure what that means. There are three types of transformers. Number one, encoders. An encoder-based transformer takes text or other data as input and outputs a dense representation or embedding of that text. Example, BERT from Google. Use cases, text classification, semantic search, named entity recognition. Typical size, millions of parameters. Decoders. A decoder-based transformer focuses on generating new tokens to complete a sequence, one token at a time. Example, Llama from Meta. Use cases, text generation, chatbots, code generation. Typical size, billions in the US cents, uh, in other words, 10 to the 9. I don't know what other sense there is of the quantity of a billion of parameters. Uh, Seek to seek encoder dash decoder. A sequence to sequence transformer combines an encoder and a decoder. The encoder first processes the input sequence into a context representation, then the decoder generates an output sequence. Example T3 BART, use cases, translation, summarization, paraphrasing, typical size, millions of parameters. Although large language models come in various forms, LLMs are typically decoder-based models with billions of parameters. Here are some of the most well-known LLMs. Model DeepSeek R1, provided by the company DeepSeek. ChatGPT 4, provided by the company OpenAI. Llama 3 by Meta, also known as Facebook, their AI research team. Small LM2, Hugging Face, is its own provider. Uh, Gemma, Google is the provider of that, and Mistral, provider of that is Mistral. The underlying principle of an LLM is simple yet highly effective. Its objective is to predict the next token given a sequence of previous tokens. A token is the unit of information an LLM works with. You can think of a token as if it was a word, but for efficiency reasons, LLMs don't use whole words. For example, while English has an estimated 600,000 words, an LLM might have a vocabulary of around 32,000 tokens, as is the case with Llama 2. Tokenization often works on subword units that can be combined. For instance, consider how many tokens interest and ing can be combined to form interesting or interested can be, yeah, for example, consider how the tokens interest and ing can be combined to form interesting or interested. Or ed can be appended to form interested. You can experiment with different tokenizers in the playground, in the interactive playground before. So we don't have to have a token for the word interest, for the word interesting, or for the word interested. Um, Instead, we can have uh, tokens for the part of the words, and then string the tokens together, so that that can reduce the amount of vocabulary you need. All right, so here's the tokenizer playground. Experiment with different tokenizers running locally in your browser. So let's play with the let's go with the Hugging Face tokenizer. So it's going to be small, right? SMOL. I don't see it. Well, everyone loves Claude. Let's use Claude. All right, and then let's type out some text to see how Claude d decides to tokenize it. So, okay, so we've got 16 tokens. So we can see the apostrophe S, obviously its own token. You could pop that out of words. But one thing that's interesting that it didn't do is this decides. It didn't tokenize the ES. Let's take a look and see if there's other ones that did decide to tokenize the ES. Interesting, because I would have thought that would be an ES would be here we go. So we do have one. So this one is Llama decided to tokenize IDES. So you can just plug that into prefixes and you get a lot of different words without having to learn the vocabulary of the words. So they have the prefix space DEC as a token, and they have IDES as a token. So they can just combine these to come up with the word the sides. And the other models decided to do it so that the word the sides itself is a complete token. Yeah, I thought there might have been. Yeah, and here's a token that decided to tokenize an S to just plug that in. So that's kind of I'm surprised I'm surprised that more models didn't tokenize the ES or the IDS or just the S. I'm surprised we only saw two models that did that. Each LLM has some special tokens specific to the model. The LLM uses these tokens to open and close the structured components of its generation. For example, to indicate the start or end of a sequence message or response. Moreover, the input prompts that we pass to the model are also structured with special tokens. The most important of those is the end of sequence token, EOS. The forms of special tokens are highly diverse across model providers. The table below illustrates the diversity of special tokens. Okay, so these are tokens that are not something you would see in a sentence, they would be hidden from the user. GPT-4, um, so yeah, and we can see there's no standardization of these tokens. For each of these providers, they've decided to use a different end of sentence token. And we can see some of these are clearer than others. I like the DeepSeek one because GPT-4 end of text. What does that mean? Is that end of because this is an end of sequence. Okay, it's not end of sentence. So when I said end of sentence, bad, bad, bad. That gave a bad impression of what it actually means. It means end of sequence. So a tokenized sequence can be a sentence, a paragraph, whatever. Which is interesting that DeepSeek decided to explicitly say end of sentence because end of a sequence token. I'm not sure if that necessarily always corresponds to the end of a sentence. This is funny. It says I'm end of turn. So no standardization. We do not expect you to memorize these special tokens, but it's important to appreciate their diversity and the role they play in the text generation of LLMs. If you want to know more about special tokens, you can check out the configuration of the model in its hub repository. For example, you can find the special tokens of the small LM2 model in its tokenizer config.json. Understanding next token prediction. LLMs are said to be autoregressive, meaning that the output from one pass becomes the input for the next one. The loop continues until the model predicts the next token to be the end of sequence token, at which point the model can stop. Let's take a closer look at this. So decoder, LLMs, decode. Okay, so we can see it's auto-regressive. It's yeah, until it predicts an EOS token. There you go. All right. In other words, an LLM will decode text until it reaches the EOS. But what happens during a single decoding loop? While the full process can be quite technical for the purpose of learning agents, here's a brief overview. Once the input text is tokenized, the model computes a representation of the sequence that captures information about the meaning and the position of each token in the input sequence. This representation goes into the model, which outputs scores that rank the likelihood of each token in its vocabulary as being the next one in this sequence. Let's take a closer look at this one. All right, so Paris is the city, dot, dot, dot. We tokenize the prompt. Paris, okay, so tokenize it. There we go. And then, okay, then we decode to logits. Remember logits from this book? We select the max value. There we go. Based on these scores, we have multiple strategies to select the tokens to complete the sentence. The easiest decoding strategy would be to always take the token with a maximum score. You can interact with the decoding process yourself with small LM2 in this space. Remember, it decodes until reaching an EOS token, which is IMN for this model. So let's decode the sentence. The capital of France is, yep, so it could be any of these. So, it could be the capital of France is the place to be. The capital of France is, yeah, so Paris, yep. And then from there, uh, oh, that's interesting. The conclusive sequences are the one that end in, oh, I see. So it's predicting a space next. Oh, it's predicting a period. Okay. Got it. The conclusive sequences are the ones that end in an end of text token or at the end of generation. Output sequences. Okay, so you are helpful, chatbot. The capital of France is Paris. So we can modify this, and we can see the capital of France is not. Let's see what it says for that. So the capital of France is not. That's interesting. So we can see it basically did a similar thing. So that didn't work well because there's other cities in France. So like I would think that what it would do, this is where this technology breaks down, right? Because the top cities in France, number one everyone knows about is Paris, but like Dijon, like you could imagine somebody because of the Dijon mustard might think that Dijon is the capital of Paris, or a Lyon or Nice or Bordeaux, you know, like yeah. So you can see it kind of breaks down. Um, let's do she sells seashells by the and then decode. Yep. So there we go. Yep. So it got it seashore, but let's see how it tokenized it. It tokenized it to SE, and then from there it predicted ORE, and then it predicted a period, and then it predicted a uh, an end. But it came very close to making other choices. Each these only won by a little bit, but there are more advanced decoding strategies. For example, beam search explores multiple candidate sequences to find the one with the maximum total score, even if some individual tokens have lower scores. So here's beam search visualizer. Play with the parameters below to understand how beam search decoding works. Here's GPT-2 doing beam search decoding for you. Parameters. Sentence to decode from. Inputs. The input sequence for your decoder. Number of steps. The number of tokens to generate. So max new tokens. Number of beams. Num beams. The number of beams to use. Length penalty. Length penalty. The length penalty to apply to outputs. So if you have it longer than 0, it promotes longer sequences, while length penalty less than 0 encourages shorter sequences. This parameter will not impact the beam search paths, but only influence the choice of sequences in the end towards longer or shorter sequences. Number of return sequences. The number of sequences to be returned at the end of generation should be less than or equal to the number of beams. Remember, beams weren't explained yet. Okay, so sentence to decode from. Conclusion. Thanks a lot. That's all for today. So let's run it. Okay, so here we go. The conclusive sequences are the ones that end in an end of text token or at the end of generation. Remember, this is GPT-2, so it's a different end of sequence token. They are ranked by their scores as given by the formula score equals cumulative score divided by uh, output length, and then there's two asterisks there. I don't know what that means. I don't think it means multiplication. Maybe it means output length raised to the exponent of length penalty. Or yeah, I don't know why there's two there. Only the top num beams scoring sequences are returned. In the tree, they are highlighted in blue. The non-selected sequences are also shown in the tree, highlighted in yellow. Output sequences, um, there we go, score. Okay, so we can see there's different choices it could have made. Ultimately, what it did was, thanks a lot. That's all for today. Blah. I hope you are enjoyed. That's all for today. I'll be back. So the one that was the best answer, it actually went with, or I don't think it did go with. I'm not sure. Anyway, moving on from that. If you want to know more about decoding, you can take a look at the NLP course. Attention is all you need. A key aspect of the transformer architecture is attention. When predicting the next word, not every word in a sequence is equally important. Words like France and capital in the sentence, the capital of France is, carry the most meaning. Yeah. This process of identifying the most relevant words to predict the next token has proven to be incredibly effective. Although the basic principle of LLMs predicting the next token has remained consistent since GPT-2, there have been significant advancements in scaling neural networks and making the attention mechanism work for longer and longer sequences. If you've interacted with LLMs, you're probably familiar with the term context length, which refers to the maximum number of tokens the LLM can process and the maximum attention span it has. Prompting the LLM is important. Considering that the only job of an LLM is to predict the next token by looking at every input token and to choose which tokens are important, the wording of your input sequence is very important. The input sequence you provide an LLM is called a prompt. Careful design of the prompt makes it easier to guide the generation of the LLM toward the desired output. How are LLMs trained? LLMs are trained on large data sets of text where they learn to predict the next word in a sequence through a self-supervised or masked language modeling objective. From this unsupervised learning, the model learns the structure of the language and underlying patterns in text, allowing the model to generalize to unseen data. After this initial pre-training, LLMs can be fine-tuned on a supervised learning objective to perform specific tasks. For example, some models are trained for conversational structures or tool usage, while others focus on classification or code generation. How can I use LLMs? You have two main options. Number one, run locally if you have sufficient hardware. Or number two, use a cloud slash API. For example, visit the Hugging Face serverless inference API. So this is what I'm reading about now in this other book is how to select your LLM and your method of using it. Throughout this course, you will primarily use models via APIs on the Hugging Face hub. Later on, we will explore how to run these models locally on your hardware. How are LLMs used in AI agents? LLMs are a key component of AI agents, providing the foundation for understanding and generating human language. They can interpret user instructions, maintain context in conversations, define a plan, and decide which tools to use. We will explore these steps in more detail in this unit, but for now, what you need to understand is that the LLM is the brain of the agent. That was a lot of information. We covered the basics of what LLMs are, how they function, and their role in powering AI agents. If you'd like to dive even deeper into the fascinating world of language models and natural language processing, don't hesitate to check out our free NLP course. Now that we understand how LLMs work, it's time to see how LLMs structure their generations in a conversational text. To run this notebook, you need a Hugging Face token you can get here. You also need to request access to MetaLlama models, and the that's a 404. Uh-oh. Um, okay. For example, you can find the special tokens of the small LM2 model in its tokenizer underscore config.json. If you'd like to dive even deeper into the fascinating world of language models and natural language processing, don't hesitate to check out our free NLP course. All right, so here's the next part of the course. It's a pretty long course. Yeah, so we can see the course breakdown. Um, where am I in Unit 1? Not sure. But anyways, it says about 4 hours per week, and it's probably an underestimate. Yeah, next would be tools. So let me take a look at the clock at the hour mark. Okay, so that's going to be it for this video. Thanks for watching, and see you in the next one.